it's not that SaaS is dead, but that's something which was recently raised by Satya Nadella as to how the SaaS architecture is changing. And I've been talking to a lot of different stakeholders in the AI industry as to how things are evolving, and I felt that it's important that uh, we at Data Pilot bring some perspective to this and our opinion as to how it should be done, right? So SaaS is definitely not dead, but it's important that organizations are evolving with the changing dynamics of AI world, specifically the agentic AI world, and how agentic AI needs to be incorporated in your existing SaaS applications, be it monolith, be it microservices. And I'll be, talking about some opinions of our own as to how we feel this could be done and what are the best practices, because there's a lot of noise overall, specifically on LinkedIn. But it's important that all the different, data architects, software architects, chief data officers, and so on and so forth are actually future-proofing their architectures and know how to do this the right way. And there could be rights and there could be wrongs. And generally, if we talk about AI agents and are they the next evolution in software architecture? Um, and definitely with the advent of AI agents, you know, it's important that your software architecture is future proof to incorporate the agentic workflows um, you have, or let's say you're building in your organization, right? So we're observing that we're moving from traditional software to AI native systems that can adapt in real time. Unlike static rule-based architectures of the past, AI-driven architectures, are dynamic, self-optimizing. In a sense, the system itself can learn and adjust, improving efficiency and resilience without constant human intervention. But we talk about, agentic AI agents. Everyone is doing AI, and specifically after ChatGPT, we usually come across a lot of different key stakeholders in the organization where they will ask that, just do AI or just do it, right? But it's important to understand what AI is and specifically what agentic AI is, right? So agentic AI refers to AI systems made up of autonomous agents that can reason, plan, and act to achieve goals without minimal human input. What does that mean? So essentially, you're delegating a task to an AI agent within your existing business workflows to complete it end to end with some human in the loop sometimes and sometimes completely autonomous, right? So agents sometimes are partially autonomous, fully autonomous, right? Or actually not even autonomous, that they have to be triggered, right? Where, you could take an example of something like ChatGPT or Claude, where you're triggering it through a prompt and it gives you a response. Partially is basically some human and some done by an AI agent, which is, let's say, responsible. An AI agent was responsible to extract text from a PDF document and put it into your system. But currently, what happens is that there are a lot of data entry operators looking at PDFs and putting it into your software application or your ERP, right? Imagine all of this replaced by an AI agent, and in the end, there's just a human in the loop just to ensure that the data which is input in the system is correct, and you click approve, and the system takes care of the rest, right? Um, Generally, when we talk about AI agents, instead of one monolith AI model, you have multiple specialized AI agents which are responsible to fulfill different business workflows as a team. And that's where I'll sort of touch up on agent to agent communication, because a lot of times, especially because we are in the era where some companies have AI agents and some are building, but it's important to understand how multiple AI agents would work in a team. Right? Imagine this as a development squad with a front end, back end, UI, UX, QA, and so on and so forth, working together to achieve a goal. But imagine this is all autonomous and agentic, where there are robots taking care of fulfilling a specific task. and working together and communicating with each other to fulfill several different business workflows. Talk about enterprise adoption, right? I spoke about some organizations adopting AI agents. Some are actually thinking how to do it the right way. And some are getting pretty mature where they've rolled out several AI agents in production, right? 10% of organization already use those. 50% plan to adopt them within the next year. That is huge. Like, by 2026, you'll have like 50% of organizations adopting them, right? And 82% plan to integrate AI agents within the next 3 years. That's survey from Capgemini, right? Um, the question here is, why does it matter now, right? So agentic AI is poised to transform the enterprise software architecture ecosystem, right? It's often compared to the cloud revolution in terms of impact, enabling levels of automation and intelligent workflows, managing previously impossible tasks, sorry. Business leaders are now interested because, this technology promises end-to-end solutions, right, that autonomously drive business outcomes. So what that means is that business owners are now realizing that if you delegate redundant tasks to AI agents, you could actually save cost, right? And a lot of cost, right? But that doesn't mean that you're essentially replacing humans completely. You're essentially adding an assistant or a co-pilot for humans to fulfill specific business workflows, right? And as I go along in the webinar, I'll touch up on different aspects of different use cases which could be relatable in your organization and how they could result in business impact, right? The dilemma with traditional architectures, and I'm sure that a lot of people, have heard about this, that there is a monolith architecture and there's a microservices architecture, right? I'm sure I'd have software architects. I'm sure I also have software engineers and so on and so forth, in the webinar. It's important to understand a monoliths and microservices, but why are they not, let's say, or how can you actually, let's evolve these architectures to incorporate agentic AI? And what is the best way to do this? So when you talk about, monolith architectures, traditional monolith architectures become bottlenecks when scaling or updating to handling AI tasks. Any small changes, let's say you're integrating a new AI model, can require rebuilding and redeploying the entire system. So that essentially slows down innovation. Monoliths are tightly coupled, and if you're in one part, can break everything because there's one code base. And for AI workflows, which are often involve iterative processing of data and model updates, this lacks modularity and agility in a very significant manner, right? So microservices probably better, but still not AI native. So basically microservices breaks your app into independent services, improving scalability and deployment. However, vanilla microservice architectures assume asynchronous or synchronous request response interactions that struggle with AI needs. So AI agents don't fit neatly into a single request response. They may need to gather information from multiple sources, wait on events, and perform long-running reasoning loops. So classic microservices might time out or break if an AI process takes too long or calls many services in sequence, because you understand that in microservices, it's an event-based architecture. All the microservices are speaking to each other. And since in that, if you introduce an AI agent layer, which is also speaking to each other, it becomes really complex for communication as well as troubleshooting, right? Which probably I'll touch up, and you'd sort of understand how things come together. Moreover, a network of dozen microservices can become really complex, essentially coordinating with different AI workflows. And imagine that if each call is tightly coupled, right, within a microservices architecture, it could become like, a pain when you're actually bringing AI workflows into that. So in short, traditional microservices were not designed for the asynchronous data incentive, iterative nature of AI agent workflows, right? But generally, so we're in the AI agent era, so I'm talking from that perspective, right? So generally, when we talk about monoliths and microservices, they lack native support for things like real-time learning on multi-step reasoning or autonomous decision-making, right? They excel at deterministic transactions. So you could, place an order. There's an order service, and then there's another inventory service. The order service essentially talks to the inventory service to fulfill one order. But then the problem is, since microservices, it's so much interaction between different services, and including multiple agents within a microservices architecture could actually be really complex for software architects and software engineers to manage, right? And this sets the stage for, the next architectural approach, which I'm going to propose as to how you should incorporate AI agent workflows within, your software stack, your architecture. So, and we're calling this as a hybrid architecture, right? So what is the hybrid architecture, right? It is essentially blending the old and new. So rather than discarding proven practices, leading organization should adopt a hybrid architecture, combining traditional backend systems with a new AI agent services. So in this model, actually what's going to happen is that microservices would handle well-defined critical business functions, while AI agents manage the complex, ambiguous tasks that require cognition. So what's going to happen is that you're not going to be having like a very standard conventional microservice. You will actually have a backend service and then several AI agent services. So one backend service, imagine it's a monolith architecture, and then you have multiple AI agents which are actually fulfilling one business workflows, which could evolve as looking as a microservices architecture. Why? Because one backend is taking care of standard business processes. For example, sign up. For example, adding a new user to your platform, or for example, email notification and like standard. This approach leverages reliability, performance, and clarity of microservices together with adaptability and intelligence of AI agents. The reason why I call it microservices is because it's one service, the backend, which is your general standard backend service, only one, not like broken down in microservice architecture, but the AI agents services are separate. So each backend can call a separate AI service. Okay, please process my PDF for extraction. Okay, please send an email based on ABC or based on this specific process in my system. Number three, please summarize my emails and show me the response. Just giving you ideas or use cases which are relevant to people, generally everyone, right? So this is evolution but not revolution. So you don't have to rebuild your entire platform overnight, right? Many teams start by augmenting existing systems with AI capabilities. For example, adding an AI-driven recommendation service alongside your existing e-commerce backend, right? So I'm sure you must have looked at product recommendations on Amazon, right? Imagine there is a standard backend responsible for fulfilling orders and everything, just one code base on Amazon.com, but there's another service which is responsible for giving you AI recommendations. What are you doing? You're actually specifically building a service which is responsible for giving you recommendations for logged in users. And what that does is no load on your existing backend. Your backend talks to that AI service, which is essentially a recommendation service, call it as an agent, which provides personalized products to logged in users based on their history. So you're actually dividing your traffic on multiple AI agents. And a lot of times we do this when we deploy ML models or AI models where it's a REST API call. But in AI agents, it's going to be much different because a lot of times we're not, storing the data of a service separately. A lot of times the monitoring and observability stack is missing. There's a lot of security and governance issues that LLMs come into play, and I'll talk about that, right? So the key is that the new AI service integrates with the old Y APIs or event streams, right? Think of this as adding a smart co-pilot module to your robust engine, right? So this phase approach proves value early and minimizes disruption, right? Now, how does the architecture look like? And that's the anatomy of the new architecture, which we're calling hybrid architecture, right? There's a client request and there's an API gateway, right? Now, what is the API gateway doing? So the API gateway is essentially dividing, or let's say responsible for routing the request to the specific layer on your left, which is this, and blue on the right. That's an AI agent. And that's how, you're making your software architecture AI, right? So what you're doing is an AI API gateway has all the logic. As the client request would come, you would either go through traditional backend, where let's say, I mentioned this earlier as well, sign up, traditional process, separate backend, and API gateway routes it here. It essentially takes care of, doing all the processing and response to the client. Okay, success, you've signed up, right? Now, it's important to understand one thing, that if you talk about this layer, this one, there's a database here, right? So there's a database here, right? Which is doing all the standard processing and standard business workflows in your, in your software, in your ERP, in your system. And that's where it gets interesting, the AI agent layer, right? Now, there are a lot of different, opinions or thoughts or best practices, but you see that there's a vector database here, because AI agents sometimes were powered by LLMs. So LLMs understand, or LLMs make data queryable when it's vectorized in a vector database. So when LLMs call your operational database, that's an NLP to SQL system. What that means is, tell me my orders for the last 7 days. That's an LLM with a traditional database to give you a response on a SQL query. But let's say there's unstructured data and you want to query that. You do that every day on ChatGPT, right? What is happening actually? All this data, which is fetched from the internet by OpenAI, is actually created into embeddings and then stored in a vector database. Imagine this as ones and zeros, which represent unstructured data, which could be text. But the LLM enables querying them. That could be one. Or sometimes AI agents could, involve just using standard libraries like OCR, Paddle OCR, or let's say, you're supposed to, scrape data from a website and respond. That's an AI agent, where the AI agent is responsible to the scrape data. Let's say there's no LLM involved. In that case, you're just using something like Selenium, or let's say CRUD-AI, for example. So it depends based on the business use case. But what's important here? The important piece here is, one is a combined database, which could be used by several AI agents. And another approach here is, I'm not sure if, just imagine this as a box, right? Multiple AI agents, which are responsible for completing several tasks, but each agent having a separate database of logging and monitoring. That's where you need to understand that each agent actually carries its own database as well. And then all of these could be actually talking to this, and this could also be talking to this, right? Some data, and through, let's say, an API layer, right? Some logging and some, I'll give you an example. If I'm doing PDF data extraction through an AI agent, it would have its own database, as well as push the extracted data into the system, and then it starts appearing here in a database, right? So very important to understand this.